All right, hi everyone. This is lesson 5 group problems for Elsa Goodson, Nathan Burton, Macon Hampson, and Sarah Brodman. And so I'll just go through these. So number 1, we're determining the allele arrangement in the heterozygous parent. So we have Mg plus, Rg, and A plus because they're the parental genotypes on the most numbers of offspring, and then Mg, R plus, and A. And then for B, we have the gene order. So the agouti gene is going to be the center gene because that's the one that's going to have the double crossover. And then that makes the gene order Mg plus A because A needs to be in the middle, and then Rg. And then for our linkage map, we're going to have our numbers are going to come out to 13.1 MUs between the mahogany and the agouti. And then for the agouti and ragged, we're going to have 17.5. And then when you multiply those percentages together, we get 4.72 for our bottom number in the C fraction. So then our interference number that we stick into that, the 1 minus that number is going to be 0.4225, which is going to have us come out with a 57.7 positive interference value. And then for number 2, we address it the same way. So we just look for the parent genotypes that come off with the most number of offspring. So the gene arrangements are going to be SC plus, S, and V, and then SC, and then S plus and V plus for the gene arrangements. And then the gene order, we're going to have SC be in the center. This is the only one that moves because we can see that the SC is the one that creates the least number of offspring in that order. And then for our linkage map, we're going to have the numbers that add up for that to be the 150 and then 156, 10, and 14. We're going to divide that by 1,000, get 33 map units. And then the other one, we get 10 map units. And when we stick the number into the C equation, we're going to get out 16 over 19.8 for a fraction. That gives us 0.808. And then we put the 0.808 in our I equation. That's 1 minus 0.808. We get a 24% positive interference there. And then for number 3, for our gene arrangements, same thing. The parental genotypes we have are going to be the C with the G plus and the S plus. And then we're going to have the C plus with the G and the S. And then for the gene order, we figured that the center gene is going to be the striped thorax gene. That's going to be the one that does the double crossover. And then when we set that into our linkage map, we're going to have the 56 map units between the G and the S, and then the 1.9 map units between the glassy eyes and the striped thorax. So then that creates our interference value at interference value is going to be 100% interference value because we're going to divide that 0 number of offspring because we only have 6 progeny genotypes here, which we're supposed to have 8. So there's 2 that have 0 progenies. So we're going to divide the 0 by our C number of 1. And then that's going to create a 100% interference value. And for number 4, So our gene arrangements for number 4 are going to be BR, F, and AN plus, and then BR plus, F plus, and AN. And that is going to create the F allele in the center. That's the one that's going to be doing the crossovers to create those genotypes there. And for linkage map, we're going to have between the BR and the Fs, we're going to have 51 map units. And then between the F and the Ns, we're going to have 190 map units. And then that's going to create our interference value in the C fraction is going to be 5 over 9.7, which is going to be 0.5154. And then when we put that into the interference equation with the 1 minus 0.5154, we're going to get a 48.5% positive interference value. And for number 5, so for A, we got when you breed the heterozygous parents together, you're going to get a 25% frequency for capital A, capital B, and then a 25% frequency for capital A, lowercase b, and then 25% frequency for lowercase a, capital B, and a 25% frequency for lowercase a, lowercase b. And then for B, when the A and B genes, capital A and capital B genes are linked, and the lowercase a and lowercase b genes are linked, we're going to get a 50% frequency for the capital A, capital B, and then a 50% frequency for lowercase a, lowercase b. And then those other genotypes that we mentioned in A are just going to be at 0%. And for C, if the crossing over does occur, then the genotypes that we will get are capital A, capital B, and then capital A, lowercase b, and then lowercase a, capital B, and then lowercase a, lowercase b. And then for question D, we weren't 100% sure on this problem, but when we all talked it out, we decided that if we're given a 7.8 map units value, we're gonna have an occurrence of 3.4% for each genotype, because we're gonna divide that 7.8 divided by 2, since we have just those 2 genotypes. So that will give us a 3.4% frequency for each of the gametes produced in the cell in question C. So that is our group problems for this week. Thank you.